In this question, we're asked to graph a quadratic relation that's in vertex form. And a good method of graphing a quadratic relation in vertex form is to use transformations. So we'll start with the base graph y equals x squared, which we know from doing the table of values for y equals x squared so many times, that we have the point 0, 0, 1, 1, 2, 4, negative 1, and negative 2, 4 on our base parabola y equals x squared. Now we'll begin to apply the transformations. We have an a value of minus 1/2. Because it's a minus, that's going to cause a reflection through the x-axis, and the 1/2 will cause a compression, a vertical compression, by a factor of 1/2. We can make both of those transformations happen by multiplying the y values from our base graph by that a value of minus 1/2. So here my y value is 1. If I multiply by minus 1/2, we have minus 1/2. Here my y value is 4. If I multiply by minus 1/2, I end up with minus 2. Here the y value is 0. If I multiply by minus 1/2, we still have 0. Here the y value is 1 times minus 1/2 is minus 1/2. Here the y value is 4 times minus 1/2 would give us minus 2. So here we have the graph y equals minus 1/2 x squared. We've applied the a value only, and so this new parabola, the only thing it would have in its equation besides a y and an equals and an x squared is just that a value. After you apply the a value, you can move on to the translations. So we're going to translate to the right 3. So the number that's added or subtracted inside the brackets is always the horizontal translation, and it's kind of the opposite of what you'd expect. Seeing a minus 3 there might make you think you should translate to the left 3, but we have to remember that the horizontal translations kind of work backwards. They're not very intuitive. We have to move to the right 3. And the minus 5 out here is telling us to translate down 5 units. We could do these transformations at the same time. We'll take each point and translate to the right 3, down 5. Take my next point to the right 3, and down 5. Next point, again, to the right 3, and down 1, 2, 3, 4, 5. Take this point next, to the right 3, 1, 2, 3, and I have to be careful when I'm counting down 5 that I'm counting from half square to half square. 1, 2, again to midway through the square, 3, 4, 5. And my last point, translate to the right 3, and down 1, 2, 3, 4, 5. This blue graph has had all of the transformations applied to it, so when I write out the equation, there should be nothing left out. We've taken care of everything. And there we have it.